find the magnetic field due to the second wire. That has a current flowing into the page. I2 equals I. It creates a magnetic field at the tip of the triangle. That magnetic field is a big circle with I2 at its center. The orientation of the circles are our thumb goes into the page and our fingers show the orientation of the magnetic field, so it's coming along this way, so the magnetic field has to be tangent to the circle, come up this way. Tangent to the circle would be the same as perpendicular to the radius, so our B2 comes up this way. The magnitude of our B2 is equal to mu naught times I2 over 2 pi r. Remember that I2 is given by the magnitude of the current I. Let's see what we can think about the angles here. So let's see, if we draw a horizontal line right here, if we draw a line that keeps coming up through right here, and if we drew a vertical line right here, so here, let's see, how will we think about this? So here to here, this is a 30-degree angle. This is a 30-degree angle because that bisects a 60-degree angle. That makes this 30 degrees. This angle also has to be 30 degrees because from here to here is a 90, so that's 30. And this angle here also has to be 30 because here to here has to be 60, and that B2 cuts right through the center. So it's 30 degrees above X. Let's find the force created by wire, magnetic field created by wire 2. So our magnetic force, we can get the direction with our right-hand rule. So current I3 is coming out of the page here. Out of the page. So our thumb goes with the current, our finger goes with B2, and then our middle finger shows the force, so it comes straight up perpendicular to B2. So here's our force F2. Let's get the direction of that guy. So if we draw a horizontal line here, these two angles are the same, that's a 60, so this has to be a 60 degrees. So our force F2 equals I3 times the length of the wire crossed with B2. So the magnitude of the force is going to be I3 times the length times B2, which is mu naught I over 2 pi r. And the angle is 60 degrees above the negative X. So there's our force F2. We can put this force on our previous picture. We knew the total magnetic force had to point up. It has two components. It has one due to force from wire 1, one force due to wire 2. We'll add those two vectors together. We'll see that the X components cancel and the Y component points up. So for the next part, we'll find the net force and we'll use that to find the magnetic field.